Morning class. Today we'll be talking about the properties of a trapezoid. So let's identify this first. Is this figure a trapezoid? Yes or no? Yes, it is a trapezoid. How about this next one? Yes, it is still a trapezoid. Very good. Next, yes or no? Yes, this one is also a trapezoid. So what is the definition of a trapezoid? A trapezoid is also known as trapezium is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. On the figure below, the bases or the bases and the parallel sides are these sides here, side AB and side DC. The other two sides are called legs, this side here. Bases are not always horizontal. It could be vertical, it could be slanting as well. It goes with the side that is or that are parallel. So for this figure here, these are the bases and these are the legs. There are three types of trapezoid. First is the right trapezoid. It has a pair of right angles. So this is the first type of a trapezoid. Next, scalene trapezoid. It neither has equal angles nor has equal sides. And lastly, isosceles trapezoid. It has equal length of non-parallel sides, or the legs. The legs are equal. A trapezoid has two pairs of base angles. So for base AB, the pairs of base angles there is angle A and angle B. And for base DC, the pair of base angles there are angles D and angle C. The sum of the interior angles of a trapezoid is equals to 360 degrees. So we can say that angle A plus angle B plus angle C plus angle D is equals to 360 degrees. This is applicable to all types of a trapezoid. Find angle C. So for this one, we have here the given. Angle A 103 degree, angle B 119 degrees, and angle D 77 degrees. And we're going to find the value of angle C. Since the sum of the interior angles of the trapezoid is equal to 360 degrees, we can say that angle A plus angle B plus angle C plus angle D is equals to 360 degrees. Now we're going to substitute the values of the given angles. So angle A 103, angle B 119, angle C the missing angle, and lastly angle D 77. And we're going to equate it to 360 degrees. We're going to transpose um, the known values to the other side of the equal sign. So it would become angle C is equals to 360 degrees minus 103 minus 119 minus 77. And we can get the value of angle C, which is 61 degrees. Angles between the parallel lines add up to 180 degrees. So that means that angle A plus angle D is equals to 180 degrees. Also, angles B plus angle C is equals to 180 degrees. So this theory or this theorem is applicable to all types of the trapezoids. Could be right trapezoid, could be scalene trapezoid, or the isosceles trapezoid. So the parallel side here, or the parallel lines here, are lines AB and line DC. So the angles in between A and D equal to 180, A and D equal to 180, and B and C is also equal to 180. Find the missing angles. So we have here a given figure which is a scalene trapezoid. So the missing angles here are angle A and angle C. We're going to find angle A first. Since angles between the parallel lines add up to 180, so we can say that angle A plus angle D is equals to 180 degrees. Angle D is given 81 degrees, so we're just going to substitute that to our formula. So it would become angle A plus 81 is equals to 180 degrees. Then we're going to transpose 81 to the other side of the equal sign in here. So it would become angle A is equals to 180 degrees minus 81 degrees. So we can get the value of angle A, which is 99 degrees. Now we're going to find angle C. So since angles between parallel lines add up to 180, we can say that angle B plus angle C is also equal to 180 degrees. Since angle B is known, which is 125 degrees, then we can just substitute that to the formula. 125 plus angle C is equals to 180 degrees. Now we're going to transpose 125 to the other side of the equal sign. Say that angle C is equals to 180 minus 125 degrees. We can get now the value of angle C, which is 55 degrees. Let us discuss isosceles trapezoids. If the legs of a trapezoid are congruent, then the trapezoid is an isosceles trapezoid. So the congruent side here, or the congruent legs here, is side AD and side BC. Next, if a trapezoid is isosceles, then each pair of the base angles is congruent. So we have here angle A is congruent to angle B. This is for isosceles trapezoid only. Applicable for isosceles trapezoid only. Base angles are congruent. Angle A is congruent to angle B. And angle C is congruent to angle D. Again, this is only for isosceles trapezoid. Applicable for isosceles trapezoids only. The given figure here is an isosceles trapezoid. So we're going to find the missing angles. There is only one angle given, that is 53 degrees. So we're going to find angle B, angle C, and angle D. Since each pair of the base angles of an isosceles trapezoid is congruent, then we can say that the angle B here is also 53 degrees, congruent to angle A. We already knew that sum of all the interior angles is equal to 360 degrees. So we can just substitute it to our formula, which is angle A plus angle B plus angle C plus angle D is equals to 360 degrees. We have here two known terms now, angle A and angle B. So we're just going to substitute those terms here in the formula. So we can have 53 degrees plus 53 degrees. Then we're going to represent angles C and D by x. So we can write plus x for angle C and plus x for angle D, since they are equal. So we can just use the same variable as the representation. Then equate it to 360 degrees. Combine similar terms, we can have x plus x, so that would be 2x is equals to 360 degrees minus 53 minus 53. Since the sign of these two will change to negative when we're going to transpose it to the other side of the equal sign. Next, we can have 2x is equals to 254. After subtracting 53 minus negative 53 and negative 53 here. Or after subtracting 53, two 53s. Okay. Next, we can have x is equals to 254 over 2. And then we can get the values of x for angle C and angle D. X is equals to 127. Find the missing angles. We have here still an isosceles trapezoid. That's our sample figure. Only one known given, which is angle A, 97 degrees. And the others are unknown, angle B, angle C, and angle D. We all know that pairs of base angles in an isosceles trapezoid are congruent. So we can say that angle D is also 97 degrees. So we're going to find the other values of or the other values for angle B and angle C. We're going to substitute um, the known values to the formula. Angle A plus angle B plus angle C plus angle D, which is equals to 360 degrees. So angle A is 97 degrees, and then plus x, so we're going to represent angle B by x, and angle C also x, since these two here are also equal, so we can just use the same variable as our representation. And then plus 97 degree for angle D, the value of angle D, equal to 360 degrees. Combine similar terms, we can have 2x is equals to 360 degree minus 97 minus 97. We can have 2x is equals to 166. We're going to divide 166 by 2. That way, we can get the value of x, which is 83 degrees. So our value of angle B is 83 degrees, and for angle C also 83 degrees. Next, a trapezoid is an isosceles trapezoid if its diagonals are congruent. So we for this trapezoid ABCD, we can say that this one is an isosceles trapezoid since AC is congruent to BD. Example, in an isosceles trapezoid, AC is equals to 9 meters. So AC is equals to 9 meters. What is the measure of BD? So we're looking for the measurement of this one. If AC is equals to 9 meters, then BD is also equal to 9 meters. Since diagonals of an isosceles trapezoid are congruent. Mid-segment of a trapezoid. Mid-segment connects the midpoints of the legs. So our legs here on the given figure are sides AD and side BC. So the midpoint of side AD is M, and the midpoint of side BC here is point N. So if we're going to connect those midpoints of the legs, we can have the what we call mid segment. So the mid segment of a trapezoid is parallel to each base, and its length is one half the sum of the lengths of the bases, or its average. So we can say that the mid segment MN is parallel to base AB, and also the mid segment MN is parallel to base DC. For the length of the mid segment, we can have this formula. Mid segment MN is equals to one half of the sum of base AB plus base DC. Example, find mid-segment MN. By the way, the mid-segment computation is applicable to all types of the trapezoid. So for this one, we have here the given. This one is an scalene type of a trapezoid, and we're going to get the value of its mid-segment. So the known base here is base AB, which has 7, and base CD, which has 13. So we're going to find mid-segment MN. So we can say that MN is equals to one half of the sum of its base AB plus DC. We're going to substitute the values of AB and DC to the formula. We can have MN is equals to one half of the sum of 7 plus 13. We can have one half of 20, which is 10. So mid-segment value or mid-segment length is equal to 10. Next example, find mid-segment AB. So the given figure here is a right trapezoid. So known values, um, base WX equal to 9 and base ZY equal to 12. And we're going to find the value of mid-segment AB. So we have the formula here, mid-segment AB, or AB is equals to one half of the sum of WX plus YZ. So since we have the values of WX and YZ, so we're just going to substitute that to our formula. So it would become AB is equals to one half of 9 plus 12. And that's one half of 21. Then we can get the value of AB, which is equals to 10.5. So our mid segment here is equals to 10.5. Find mid segment MN. Our given figure here is an isosceles trapezoid, and the missing term now is base number 1. So we can write a formula here. MN, our mid segment, is equals to one half plus the sum of its base number 1 and base number 2. Then we're going to substitute the values of the known terms. So we have here the mid-segment MN, 32 is equals to one half times X, the value of base number 1, plus 43, the value of our base number 2. We're just going to transpose one half to the other side of the equal sign. So it would become 2 times 32 is equals to X plus 43. Since if you have division here, if you're going to transpose it to the other side of the equal sign, the operation would become multiplication. Or you can just simply, from this um, statement here, you can just multiply both sides by one half, so that you can cancel out 2. So and result to this one. 2 times 32 is equals to X plus 43. So 2 times 62 is 60. 2 times 32 is 64, equal to X plus 43. So we can just transpose 43 to the other side of the equal sign. So it would become 64 minus 43, that is equals to X. So we can write 21 is equals to X, or X is equals to 21. So the value of our base number 1 here is 21. That is all for today. You have a good day.